Hello, my name is Steve Loughran. I work at Hortonworks. I'm technically in R&D. That's my official title. Unofficially, I'm somebody that breaks things. It's like testing, but not quite as official. But basically, I just break things. And I reckon that I know I've broken things. I see stack traces. If you're using Hadoop or the layers above, you've probably seen those same stack traces. So hands up who is using Hadoop, Spark, Hive, whatever to talk to. Amazon S3. Amazon S3, everybody? With the S3A connector? Amazon, yeah, okay, that's, if you've seen a stack trace, that's my code, okay, and a bit of John's. We take turns. Who's using Hadoop talking to Azure? Azure? One person at the back, okay. Google Cloud Storage. Google GCS? Okay, one person there. OpenStack Swift. Anyone? No, that's good. I say that as the author of the OpenStack Swift connector. Okay, it's not a bias against OpenStack Swift. Hands up in the room who has actually implemented any cloud data storage, such as, an S3 compatible store. Anyone in the room done that? Okay, those two people will be fielding support calls later. Hands up who's written something to do with Azure, like a storage infrastructure there. Chris wobbles his hand. Anyway, so those people there will field support calls at the end, so any hard questions, they'll go. I will be the shallow one at the beginning. So, like I said, I had promised demos. The demos are not working for various reasons, primarily laptop connectivity, but also actually Azure seems to be down, at least from this building right now. Find me over the next couple of days and say, Steve, I want to see a demo, and I might show you something working. Anyway, this is me. I break things. I fall off bicycles. This talk is about cloud storage, why it matters, where are things going. I'm trying to be discuss the technical issues rather than anything strategic, so I'll give a quick overview of things and my opinions. The first, why? The answer is everything is moving to the cloud slowly. And if you're running Hadoop in cloud, applications on top of Hadoop like Hive and Spark, you can bring up HDFS, but eventually you have to tear down your virtual cluster. HDFS goes away, so does all your data. If you want to persist data in an application running in cloud, you're going to have to save it to somewhere. And primarily, that means cloud storage. The cloud vendors, they often provide a more premium storage that looks more like a real file system, but you pay a lot for it. So cloud storage, it's the most cost effective, it scales up nicely. It also gets used a lot on-premises Hadoop clusters as a backup and restore mechanism for disaster recovery, where you really can back up hundreds of terabytes. And you can do some really interesting stuff with workflows in this world as well, where you collect data onto the cloud store, however you do it. And then even if you're running in on-premises, you can post-process it, you can collect that data so it becomes the bridge point, the way of streaming your data between other applications. And generally, no matter which application talks to cloud storage, it all comes down to the same APIs, the org Apache Hadoop FS file system APIs and its variants, and the implementations underneath. HDFS is the official implementation of what that API does, along with some Java docs and some tests. But alongside it, we have a whole suite of various connectors. I'm going to look at the main ones here. We've got Azure WASB, the Amazon S3A connector that is now the only official ASF-supported S3A connector. I'm ignoring Amazon EMR's own one. Okay, doesn't exist as far as Apache Jira is concerned. Azure ADL, Google Cloud Storage, Swift. I've already said I'm scared of that. And finally, up and coming, the new ABFS connector from Microsoft. Now, for giving demos, I'd actually be using Spark for all of this, but I'll skip that internally. The key thing is that Spark, if you're playing with it in Spark Shell, is a really good way to play with all this stuff because you can do it interactively. So, let's start with Azure first. Azure is interesting in that normally you pick a cloud store, you pick a vendor, you make your strategic decisions there, and then your choice of storage, what cloud store you're going to be using, comes from that decision. Azure is interesting and actually have a choice of 2, except soon you're going to have a choice of 3. So Azure WASB is the one that lives there. Official name is Azure Storage, but the connector is called WASB. And it is close enough to a real file system you can run HDFS. That's my metric of what cloud storage is if something you can actually run has the operations for safe HDFS transactions, then it's a file system. If you can't run HDFS on it, then it's a bit less than what you expect, and that's dangerous because it means that things may not behave as well as you'd like. So, it works. It's got a REST API. It's used a lot in production. It gets tested a lot by us in Hortonworks. It gets tested a lot by Microsoft. If there are problems with it, Microsoft do a lot of the fixing and engineering. For example, there is a patch that came in this week to speed up directory listings when you have 700,000 files in a directory. That's obviously the problems that Microsoft are hitting. It's nice that they get to do the finding and testing. So they did a lot of work in testing that stuff. We've also done a lot of work on Ranger integration. So you can do all the checks there. It's worth noting in that world, though, that Ranger, all the checks are being done client-side. So if somebody gets on the SDK, you two, pay attention. You two, third row. Attention, thank you. This is your code we're talking about here, Chris. So if you're going to use Ranger, bear in mind it's all happening client-side, so you can actually bypass it if you try hard. It's okay if you're running something like Hive, where the only thing that's going in is SQL queries, but if arbitrary code is going in, then things are vulnerable. And there is another one, Azure Data Lake, ADL, which does have Chris's name in it, at least in the papers, which is has been marketed as a data analysis specific store for Azure. It's got some very nice features. Key one is if you go to the website, there is a drop-down box where you can actually say, I want a petabyte of storage a month. And a drop-down box. That's kind of embarrassing if you accidentally click it. But $25,000, you've got a petabyte worth of storage there. You pay more for I/O, but that basically sets a baseline cost of data in this world. It's got a very nice match to Hadoop APIs. It's got a good security model. It's actually built on Yarn. It could improve a lot in client-side in terms of diagnostics of why things aren't working. Okay, an example is I got the field was something failing with the error null. It turns out that was because the JSON parser was broken. It's not the JSON parser was broken, but the JSON parser was trying to parse HTML, and nothing was checking. And the reason we're getting HTML is because the proxy settings were in the way. So it's those little brittle problems that need to get fixed. It's worth noting, actually, with all object store connectors, it takes about one iteration in the public, in the field, to actually find problems. Okay, no matter how much effort people put in the testing, it's things like can't handle HTML responses and proxy settings. They're the things that will surface. And if you're an early adopter of any of these connectors, you will be the first person to find them, I'm afraid. Now, like I said, 2 different connectors. There is now a third one up and coming. Azure Data Lake Storage Gen 2 preview. I'm getting hard stares here from Chris, who works at Microsoft. This is the name I was given to say to pronounce it yesterday. Okay. It is a successor, a forthcoming successor, due later this year to Azure Storage. The exact specifics, I'm not quite sure about. It will be bigger, better, faster, more cost-effective, etc. And it will be coming out later on this year. It is not just, it's actually a big change happening in Microsoft's cloud infrastructure in general. It is intended, as far as I can tell, to actually replace the whole of Azure Storage and WASB. So it's going to be quite a big thing. They are still developing this. They are developing the Hadoop connector in conjunction with it. So it's evolving. They've been developing it internally. It is now out in public. We have a Hadoop Jira 15407 to do it, and we actually have a branch going alongside it where we're actually merging this stuff in and testing it. It has promise. In my little local tests, it is a bit faster than the WASB connector, but I haven't done any real benchmarking. Like I said, everything always takes an iteration to be safe to use. It's interesting in that with 3 different stores in Microsoft, it's going to be interesting to see how things play out in the end. I think what the official stance is right now is that the current connector that was B uses will be going on to maintenance as far as both the REST API and the client connector goes. Everything new will happen on this new ABFS connector. Code's there, code works. If I had demos, I'd actually show you it working. Main fun is that it's going to change class path, and everyone that works in Java knows that the word change in class paths always makes people nervous. Otherwise, it works, at least as far as simple demos go. I'll have to wait and see what happens. I'm not going to demo there. We can write to walk from Spark, things like that. Relatively straightforward. Now, Amazon S3. This is the one that most people put their hands up to use, isn't it? Hands up again if you're using S3 as your connector. Everyone's put their hands down here. Is anyone using Amazon S3 as the direct destination of work from Spark or Hive? Direct destination of output. Okay. Yeah, you know about the issues here, actually. The point is that you shouldn't really be doing it without coming and talking to myself or Ryan over there. Because strength of Amazon S3, if you're running on Amazon, it's there. Weakness of Amazon S3 is it is the second, in terms of its actual consistency model, it's the second worst out there after OpenStack. You can create files, then you immediately look for them with a directory listing and they're not there. You can delete them, they're still there. You can update them and then you read them, you get the old versions. If you try really hard and you're seeking around, you can actually get a mixture of the old versions and the new versions, in theory. Though I've never actually seen that against S3. I'll point out at this point that's the Amazon S3. There are some people out there that produce an S3 for the enterprise product that actually doesn't have any of these limitations. Maybe in future, Amazon themselves might fix it. Okay, it is possible. It can be done through engineering. It just happens that they haven't actually done that yet. So, problem one, consistency of directory listings. This is absolutely critical in Hadoop-based applications because we rely on directory listings to find out what data there is for a query. We do the partitioning, we look at the directories, that's the things we schedule for our work. Equally critically, it's how the S3 connectors fake directory rename at the end of all work. When you're doing a Spark job, Hive job, MapReduce job, when a task says, I'm done, we rename the data into place. When the job's finished, we rename data into place. We fake that. There is no directories, so we can't rename a directory. What we have to do is you have to list every single file, do a copy, and then delete. If we are not getting a consistent directory listing, that copy and delete may lose data. If you're lucky, your job might fail with a file not found exception under a task attempt. This happens occasionally. You see the bug reports related to it. That's actually good because it means that your job has failed telling you that something's gone wrong. The worst is the rename may miss data and you don't notice. Everything thinks it's worked and things are gone. I want audience participation here. So hands up who's been generating quarterly reports and they accidentally discovered due to consistency problems that something was missing. Ryan. There you go, you see. Most of the time, it works. Sometimes it goes wrong and you notice. Sometimes it goes wrong, you don't notice till much later. And that's the real risk, is that things work when you're playing around. They work in demos. Every so often, it comes back to hurt you. The fix for this coming in Hadoop, it's in Hadoop 3.0, is something called CGuard, S3 Guard, which uses DynamoDB for consistency. We hand off the meta directory listings to a consistent store. Basically, we give up on relying on S3 as the single store of record of where things live. We use DynamoDB so that when we do a directory listing, we store that information, we use it as a cache. Then when I do a query, I can actually, or if I look for a file, I can just say, is the file there? And I do a head, forget file status. It comes straight back from DynamoDB, which is nice and fast. When I do a directory listing to find all those files to rename, we can list all the information we know about in DynamoDB. Then we can also go to the object store itself and do a final check. And that's not just we're listing the files we know about, we remember when files get deleted. The way the S3 consistency model is, you might delete a file and then you immediately do a listing and it's still there. What we do then for S3 is we actually store a little tombstone marker in Dynamo saying, even though the listing says it's there, it isn't really. So that's how you try and make it consistent. You look for things when they're deleted, you get the tombstone, things fail. When you update data, again, we update everything. This addresses consistency of the actual directory listings. It does nothing for the files themselves. If you've got any kind of work where you're overwriting data in place, then actually, and immediately do a get afterwards, you may still get the old data. So just be aware of that. I'll skip this low-level details, but basically, you create a DynamoDB table and bind to it, and then after that, it looks exactly like you are working with normal S3 connector. Now, fun thing, the commit problem. This is something that Ryan covered earlier in his talk about Iceberg. This is actually some work which is based on work myself, people over there in that corner, and actually some of Ryan's earlier code. As background, Hadoop jobs, Spark jobs, MapReduce. We have to deal with a world where we're trying to do work in parallel and we're trying to deal with failures. So every single task writes its data to an individual task attempt directory. When a task is ready to commit, then it actually talks to the job manager, the driver, the application master, says, I'm ready to commit. The job manager decides whether that task is going to be given to permission to commit. If it's actually allowed, then it commits its work by a rename, usually to a job attempt directory, sometimes, more dangerously, directly into place. This lets us deal with failure. If a task fails, nothing's visible, so everything's good. You can recover from a failure. It lets you do speculation. If a task, you can run two tasks in parallel. Whichever one finishes first asks the job manager saying, can I commit? Job manager says yes. The other one's told to go away. Like I said, without rename, you're in trouble here. Without consistent rename. So with CGuard, you get consistency. It's still going to take time to do that rename because we fake it by copying files. It takes 6 to 10 megabytes a second to copy a file. So again, a common problem that people come to us with is, why does my code take so long at the end of a query where it seems to be sitting around for half an hour and nothing's happening? And the answer is, because it's taking a long time to rename things and we don't bother logging this because everyone expected it to be instantaneous. If you're curious, this is a UML diagram of what the MapReduce commit protocol is. It is terrifyingly complicated. The Spark one is slightly easier. We don't have to deal with failures. But again, there's a lot of complicated chatter between the workers and the actual manager to say, am I ready to commit and not and roll back and things. So it's actually quite a dangerous area to play with as well. I'm grateful for people that have helped looked at my code, and we've been doing a lot of testing of this stuff. But essentially, what we've done is, and this is in Hadoop 3.1, provided a plugin point so that different object stores and file systems can actually commit their work without however they particularly choose. And for Amazon S3, we are not doing any renames at all. We're writing stuff direct into place. A real file system? Yes, we rely on rename being the way to commit work. But actually, object stores have their own little friend instead called put. You can write a file into place, and it's not visible until the end of the write. The secret for working with S3 then is that it turns out if you're doing a large file, we can write it a block at a time, multiple blocks, and only actually commit the write at the end. So if I got one task, I can start doing my writes as a series of posts. I post up the data. Next task, I can do it in parallel to the same destination. These files are both kind of pending commit right now. We've got the data, we know the checksums, we can basically issue a post request to make them visible. Until that point though, until you issue a post request, nothing is visible in the file system. Other applications will be reading that data, they don't see any of your work in progress. You will still get billed for it, because Amazon like to make sure you're being billed for it, but otherwise it's not visible. So then we do a job commit. We basically get that listing of everything we need to do, issue one post request for each one, which we can do in parallel, and it will all appear. It's not quite atomic there, atomic-ish would be the summary, but apart the job commit is pretty fast. It depends on the number of threads you've got going. So you get high performance, and apart from the inability to handle a job commit failure, it is resilient to things going wrong. So again, I really like this stuff. I would like to thank Ryan there for his code snippets too. This works in Hadoop MapReduce. It works in Spark as well. Here are the settings to do it. There is 2 extra files you need to sneak onto the Spark class path for it. I have a patch pending for that. But apart from that, it's fairly straightforward. There's also some nice stuff from Ryan's experience where you can actually write stuff in place with something called a partition committer that's designed to basically do live updates of an existing table in the Hive table format, where it will do conflict resolution in the final partitions. So you can basically say, I'm going to update this table for each final partition, like, you know, if you say I have year equals 2018, month equals 5, day equals 22, you can say I'm going to update, delete all the data in that directory, and you'll do a live update in place, and everything else will be left alone. So that eliminates the workflow where people quite often write to one directory and then update. Anyway, not going to show a demo here. The interesting, if you actually run this thing, it's quite hard to see what's going on. It looks like a normal write, only faster. But we update the success file. There's often a little marker file that gets stuck in after all these jobs, _success to say I've worked. Normally it's a 0-byte file. When you're using these new committers, it's actually got information about what get created and what metrics they are. So you can tell the committer was used by the fact that file is greater than 0 bytes long. And if you have a look inside, you can see what happened. Now, CSV files. We always talk about big data. People always think about Avro and Parquet and Orc and all these very large data sets. But one of the harsh truths out there is that CSV files are one of the most widely used exchange and persistent formats on the planet. Sad but true. There is actually a CSV conference, by the way. This is not a joke. Okay. But you know, you think about it, it's that big they actually have conference on CSVs and the tab v spaces arguments and things like that. So to call it a format is really ambitious, really. It's text files with various interpretations of things. It's also notable you can actually have code injection attacks in it too. So there you go. It's out there though. It's ubiquitous. It's incredibly useful in Exchange format. It's also very nice because you can generate it trivially. Any program that can generate a print line statement can generate CSV files without anything on its class path or anything like that. So one thing Amazon have actually been doing is accepting this is ubiquitous and actually providing a new feature called S3 Select that's designed to improve your performance working with S3 files by actually letting you run simple SQL queries on S3 files, on CSV files inside S3 itself. Let's see if I find a demo of it. And effectively, you can just say, you can filter and you can project. So I can basically say, select, give me from this file here, Landsat file, I can say, give me one column, and it just picks its column names from the first row of the CSV file. And then you can give select filters. You can say filter them. You can do basic, you can project, you can filter. There's a way of actually adding in a schema too, and then you can actually using basic schemas on this stuff. They also support JSON as well, which is kind of a bit less compelling. If you are going to use long-lived data sets, I think we should be using Avro instead. What's interesting about this S3 select mechanism is that it shows that Amazon have a lot more bandwidth inside S3 and externally. You give this query, it actually pushes down the predicates, the queries, into S3 itself. It will do all the filtering, and then you download your stuff locally. You only pay for the data you've downloaded, and your bandwidth is really, really fast. So this is kind of interesting if you're running in EC2, where you've got some smaller machines, and you find your bandwidth limited talking to S3. With this thing, you can be filtering around quite aggressively, and it doesn't come out your bandwidth quotas. So if you can select aggressively, if you can project aggressively, then you will actually see a performance speed up. Like I said, the limitation is it's all S3 based. I would like to see other formats. They do promise there'll be other formats on the roadmap too. And so it's actually quite interesting. If there's one thing I'll say it's a shame is that they're focusing on this rather than fixing the consistency problem. But there you go. I'm not going to give a demo here. I think one of these things is that if I do it on the normal Hadoop thing where I say, right, print everything from a 300 megabyte Landsat file and then grep, it'll take about 45 seconds to find the lines with no cloud cover. If I do the select call by sending that string straight up to S3, then it will take significantly faster, 12 seconds here. And these are timings done from this morning in this very same room. And then finally, if actually start doing projection and limiting, then you're down where most of the time is actually loading the application. It has really interesting potential. If you have massive amounts of data stored in there, it should really speed up your queries. Even so, I think if you are starting to run more than one query against a data set like CSV, you should be really thinking really hard about what formats you should be keeping your data in and move to better formats. Does some transcoding stuff too. So, I'm going to point out this stuff is not shipping in any version of Hadoop. We have a proof of concept. It's stuck up there to say, yes, we can do it. The complexity is that we have to change the whole APIs now, rather than just saying I want to open a file, but I want to open a file with a SQL query pushed in. Then we have to wire it up to the applications and the layers above. So we've shown it works. Nobody, as far as I know, is actively working on it. We're looking for volunteers. I'll be hoping the EMR team themselves will be helping, but they're not right now. Google Cloud Storage. I think one person in the room put their hand up on this. We've tended to ignore Google Cloud Storage because the code has come from Google themselves rather than from Apache. For a long time, they weren't even running the tests we write for them, which is really annoying because they were failing. But they've now fixed it. They're being a bit more proactive. They're starting to file bug reports about performance in bits of the Hadoop code itself, which means their Dataproc team are being quite profiling and finding issues with it. So they're getting more engaged. There is a talk on Wednesday, tomorrow, by my colleague Sid and somebody from Google about running Hadoop in Google Cloud. So if you really want to know where things are going, go and talk to them. Most interesting feature is, as of last Friday, they've actually come out with a Hadoop 3 adapter. Up till now, you've had to build it yourself. Now, that's a core overview of what the connectors are. What are we going to do now? Security encryption is ubiquitous. I think everyone needs to plan from this right from the beginning. Encryption is nicely widespread. All the different stores have different models of permissions and how to manage them. And then there's the actual how you do stuff, like whether you can get range and things in there. There's not a lot to say here apart from just make sure security is turned on. No one really understands S3 permission models and how to apply it to file systems in any simple way. It's notable, one group of people I know, they actually rely on security permissions to access keys to decrypt the data as their way of enforcing security. So it basically says, yes, we make the entire bucket world readable, but actually the only people that have the key to decrypt this specific bit of data are other people in a specific bit of the organization. And that's a nice way of guaranteeing access. You get billed a bit more for it because Amazon bill you for that stuff, but it means you can really check off saying nobody who's not in this group could have seen that data. It's worth playing with. Now, this CP. I am one of the people that seem to get to field support calls related to DistCP in cloud. This isn't good because it's showing up all the bits where DistCP has outgrown its world. Its original world was, I'm going to copy between two Hadoop clusters. Now it's, I'm going to back up a Hadoop cluster overnight to some cloud storage, and little things like it takes 6 hours to delete all the files afterwards is the kind of thing that gets people upset. We've got it down to 4 hours. I don't know why you're laughing there, John. So we need to do better. Also, there's still renaming going in there, and as we know, renaming sucks. So we need to do better here. I don't have anything good quite yet. I have some proof of concepts on this topic, including a little Spark uploader. Interesting enough, the people at hotels.com from Expedia have been doing some really interesting stuff on this work. There's something called Circus Train. So if you've got time on your hands, have a look on GitHub at Circus Train, which is how Expedia do their cross-cluster backups, moving stuff from on-prem to Amazon EMR and stuff off Azure and Google Cloud into EMR2. Okay, they are the people who are most active in basically a cloud-centric version of DistCP. I like to do this. I'm pointing to you. The other thing is we're all scared of going near DistCP itself because it does actually get used in such significant and critical workflows. So whatever comes, it will be an add-on on the side. Now, look at the object stores. Are they actually significantly different? The answer is they all work. You choose your object stores how they go. Again, I'm going to flag up Amazon S3 is the one, because of its inconsistency, is the one that's most troublesome. But if you're running in Amazon's cloud infrastructure, it's the one you're going to have to deal with. So you better have a mitigation strategy there. Anyway, I'll give it a quick run through. I think the key point here is that if you're running in cloud, you're going to be working with cloud object stores. They all have different quirks and issues to deal with. We try and do our best to actually test everything with this stuff. And as more and more people run Hadoop, Hive, Spark and things in cloud, the more effort we actually put into maintaining and testing this stuff. It is all open source. We would love people to find new problems, file new bug reports, supply new patches for it. And particularly, one of the interesting things we come across is different performance problems. There are just the quirks of the cloud layout is such that things that would normally work quite nicely in HDFS, like just even how you lay out your files, does not work well in cloud infrastructures where having a massively deep directory tree can trigger throttling and can really overload the system. So we need to, we need to find out where those problems are. And even though we're aware of these issues, it's actually quite hard to set up and test these things. An example is trying to write a test where you have to want to delete 10 million files. It actually takes a lot of effort to set up that test and run it. So it's not actually something we do very often. We're scared of it. If somebody does want to delete 10 million files on S3, do get in touch, okay? Because I want to do some metrics on that. Anyway, I think the final thing I want to point out is that data analytics is becoming recognized by the cloud vendors as a key use case of their cloud stores. So it's not just storing data, it's storing data for analytics. So if you look at what Azure Data Lake has been doing, if you look at what Amazon S3 Select is doing, they're basically making their cloud stores analytics-centric, analytics first. That's a good thing. The more they do there, the better it'll be for all of us. Anyway, that is me. I'm sorry I don't have any demos right now. I will be walking around building for the next couple of days, so do find me and ask to see things up and running. And are there any questions? No questions at all. Silence. Okay, question over there. If you shout, I'll repeat it, okay?
We are one of those people who use S3 as our primary object store, and we wrote this whole ecosystem of trying to handle failed jobs by having these custom partitioning things. So is using S3 card whenever it's possible for us the best way forward to handle our
Okay. Question there was, he's been using his S3 as a store of record for all their data. They've been hitting consistency problems. They've got workaround scripts to deal with it. Is CGuard the solution? It might depend on what problems you have. If it's directory inconsistencies, then yes, I think you should be using it. If it's other inconsistencies, like you delete a file and then you immediately try to open it, then you may find, or you're updating data in place, then it's not going to address it. Okay? I would certainly start with that. I'd look at using the committers as well, because we avoid a lot of the problems. If you're in Ryan's talk this morning on Iceberg, were you in the Iceberg talk? Okay, well, the slides will be up, but the work that's going on with Iceberg there is an attempt to say we will move away from relying on the directory structure as a way of documenting what's in the output of work, and actually saying we'll have a manifest file instead, and you can write the manifest robustly in a way that's consistent. But I'd be interested to know what went wrong, actually. Okay, so find me and tell me how things failed. I think is always interesting to know. Any other questions? One in the back.
Testing with on-premise S3 compatible storage, like Cloudian or something
Right,
like that?
who's testing with on3 S3 storage? The answer is those two people over there who actually work at Western Digital have been actually incredibly helpful in testing our stuff and performance and effectively tuning to make sure these things work. Anyone else that's a supplier of S3 for the enterprise, we'd love to have you come and play too, because nobody, it's not like the people work on the S3A connector, it's people working on solving their problems. We're worrying primarily about Amazon EC2 integration. They care about their stuff, and we all contribute and benefit. So if you can get anyone else to help and come in and test, it's good. Trouble spots are actually generally related to authentication, okay? And the odd stupid thing we do. For example, somebody was complaining that our connector was failing with a weird error because somebody wanted, when we try and read a 0-byte file to open, we do a get where the range is 0 to 0. And that was breaking something. Really, we shouldn't be doing a get at all at that point. It's an optimization. So anyone that tests our code, we have a good set of regression tests. People should be able to run it against their stores. They'll find problems. We can fix those problems, I think would be the summary. So, and you can run those tests yourself if you're curious. They're all public. All right? But there's no fundamental reason why it will not work with on-premises stores. Okay? Any other questions? No? Okay. Well, thank you for attending.